Hey guys, welcome back to the topic of redox. Right now, we are after completing the topic of kinetic particle theory, lab processes, purification techniques, separation techniques, atomic structure, element compound and mixtures, bonding, ionic bonding, covalent bonding, um, giant covalently bonded structures, and metallic bonding. We have completed the topic of periodic table. We have completed the topic of acid, bases, and salts. I will do some other past papers of acid, bases, and salts. No doubt, I will try to solve as many past papers as possible. Inshallah, may Allah help me in this as well. But right now, I'm going to start the topic of redox. Okay. Now the point is this: that what is redox? Okay, it seems that it will be an ox of red color. It is not. Okay, so what it is? It is a combination of reduction and oxidation. Okay, so these are the two processes which are always opposite to each other, and they are parallel to each other as well. Okay, so what is the meaning of opposite and parallel? So it means that in every chemical reaction, if there is a redox reaction, it means that there is oxidation and reduction, both are occurring. If one element is undergoing oxidation, the other partner must be undergoing reduction. What is oxidation and what is reduction? That will be our next topic. But right now, you people should understand this fact that if oxidation is happening on one way, the other way reduction must be occurring. Okay. So there are four definitions for reduction and four definitions for oxidation as well. And these four definitions are opposite to each other. Now I am changing the page and I am for oxidation four definitions. Okay. Number one thing is this: before moving towards the definition, I would like to introduce you a term. That term has been already in your mind from the knowledge of geography. Okay, what is that term? It is oil rig. Okay, it is a place from where we are digging, and as a result, we can take out the oil, the crude oil, petroleum, you may say. Okay, so what benefit we can take from this term? It is oil, and then this other part is rig. What is oil? Oxidation is loss of electron. Oxidation is loss of electron. So whenever electrons are being lost, we will say oxidation is happening. And what about the reduction? Reduction is gain of electron. I have just told it to you on the previous page that oxidation and reduction will always be parallel but opposite to each other. From these two definitions, it is very clear that these two processes are opposite to each other. How they are occurring parallel to each other, that we are going to study by applying these definitions on different chemical reactions. Okay. So I have just told you one definition for oxidation, and that is called loss of electron. Okay, loss of electron. Now, do we need to keep this term of oil rig in our mind? Yes, it will be helpful to you if you will keep this in your mind. But as this is not a scientific chemistry term, that's why it is just to help you. I am not saying you to write this in your paper. It is just to help you. Okay. So, for example, consider the formation of Na and Cl combining with each other. Consider the formation of NaCl. Okay. This is not a balanced chemical equation. I have to write two over there and two over here. Okay. You people have studied ionic bonding with me earlier. It is just telling you that when sodium is converting itself into sodium ion, sodium atom is going to lose one electron. As a result, it is shifting itself into sodium ion. So here we can say this thing that as sodium has lost an electron, you can write like this as well. It is turning itself into sodium ion. Here we can say that sodium is undergoing oxidation. Okay. How it is? Because sodium has lost an electron. That's why sodium is undergoing oxidation. Okay. I am on the next page. For example, just consider the formation of calcium and chlorine combining with each other to form CaCl2. Oh, the equation is automatically a balanced equation. Or you may consider this thing that magnesium is burning in the presence of oxygen to give you magnesium oxide. This equation is not balanced, so I have to write 2 over there. Okay. you can see this thing that calcium is undergoing oxidation. How? As it is losing two electrons to convert itself into calcium ion. Okay, so this is this. Okay, now you can say this thing that calcium Ca plus 2 ion is formed. How it is being formed? By loss of two electrons. That's why we can say that calcium atom is undergoing oxidation and turning itself into Ca2 plus ion. Here you can see that magnesium ion is being formed by loss of two electrons. You can see that magnesium is losing two electron, converting itself into magnesium ion, and that is a part of magnesium oxide. And you may write this thing that oxidation is happening over here. Yes. Why we are not discussing chlorine over there? Okay, why we are not discussing chlorine over here? Why we are not discussing chlorine over here or oxygen over here? They are undergoing reduction. How they are undergoing reduction? Let's discuss that as well. I am writing this with another color so that you people may be able to differentiate among this whole thing very clearly. Okay. Now we are talking about chlorine. Okay, chlorine is an element of group number 7. It has 7 electrons in its outermost shell. To make NaCl, chlorine is going to gain 1 electron, and as a result, it is forming NaCl, in which Cl is with the 1 negative charge. So what is the story of Cl? I am saying right now, Cl is going to gain 1 electron, turning itself into Cl1 minus. So here we can say that Cl is undergoing reduction. You people have seen this thing in your this equation, that if Na is undergoing oxidation, Cl is undergoing reduction. Okay, so this is how it is happening. It will not occur on one direction, it will not occur on one side. We cannot say that only oxidation is happening or only reduction is occurring. If oxidation is happening, reduction is happening too. So here in this equation we can say this thing that oxygen is undergoing reduction. How? Oxygen is going to gain 2 electron. As a result, it is forming O2 minus. I'm writing here oxygen is going to gain 2 electron, turning itself O2 minus, which is called an oxide ion. At the top equation, we can say that Cl has gained 1 electron, turning itself into Cl1 minus. As there are two Cl, we can write this thing that Cl2 is there and it is gaining 2 electron. As a result, it is turning itself into 2Cl1 minus. Cl is called chlorine atom. Cl1 minus is called chloride ion. So remember this thing that whenever a metal atom is converting itself into a metal ion, it is formed by loss of electron. So we can say an oxidation is always happening. Metal ion is always a positively charged ion. Okay, positively charged ion is formed by loss of electron. That's why oxidation is occurring. Okay, here I am writing with another color. If non-metal atom is turning itself into an ion, so you can say that non-metal ion, and that is a negatively charged ion. Negatively charged ion is there, and how it is going to be produced? It is by gain of electron, and we can say that reduction is occurring over there. Okay, so this is how we can say that oxidation and reduction both are occurring parallel to each other in all ionic compounds formation. Why it is so? Now just discuss this thing. Ionic compound formation, ionic compound. Okay, I should write it more clearly so that you people may not feel any problem. Ionic compound formation involves both oxidation and reduction, as ionic compound involves both metal and non-metal. Remember this thing that metallic part is undergoing oxidation, whereas non-metallic part is undergoing reduction. So this is how it is happening. Is that clear right now? This is the basic thing which you people should know. This is the basic thing which you people should keep in your mind, that oxidation is happening with metals as they are losing electron, and reduction is happening with non-metals as they are gaining electrons. Okay. So this was definition number one. Okay. Now we are saying about the second definition of oxidation and reduction, as we are discussing them in a parallel way. So we are going to discuss their definitions in a parallel way as well. Oxidation is gain of oxygen, whereas reduction must be loss of oxygen. Okay. So this is how it is happening. Let's consider an element. For example, magnesium is reacting with oxygen. We can say it is forming magnesium oxide. As the equation is not balanced, I have written 2. We can say that magnesium is, if we are not going to implement the definition of electron 1, we can implement the definition of oxygen here as well. Okay. So here, one thing should be in your mind, that in one equation there is a possibility for the application of more than one definition. Okay. So here, not only the definition of electron is implementable, rather the definition of gain of oxygen is implementable as well. Okay. So we can say this thing, that magnesium is gaining oxygen. So we can say that magnesium is undergoing oxidation. How we can apply the definition of loss of oxygen on this? Here we cannot apply the loss of oxygen definition in this equation, but we can say this thing, that magnesium is undergoing oxidation. Why? Because it has lost 2 electrons. -2 electron has occurred, -2 electron thingy is occurring over there. Whereas in case of oxygen, we can say reduction is occurring. Why reduction is occurring? As it is gaining 2 electrons in case of oxygen. Okay. So we can discuss such type of things here in this equation. But for example, let's consider copper oxide. Copper oxide is a compound which is black in color. Do we need to memorize these colors? Yes, basic colors should be in your mind. I will discuss the list of the colors in one lecture as well. Here is copper oxide. It is a transitional block element oxide, and when we are going to heat it, okay, as a result, it is converting itself into copper and oxygen. The equation is not balanced, so I have to write it like this. Okay. I can say this thing, that copper is undergoing reduction. Why copper is undergoing reduction? As copper has oxygen before reaction, oxygen before reaction, uh, but after reaction, as oxygen is lost, so copper is undergoing reduction. So here we cannot implement the definition of gain of oxygen, but here we can implement the definition of loss of oxygen regarding reduction. But in case of loss of electron or gain of electron, we can definitely implement that definition of loss of electron or gain of electron in every process of reduction and oxidation. One more thing which you people should know, that is every reaction is redox reaction? No. No, I am telling you very clearly, no. Every reaction is not a redox reactions. Which reactions are not redox reactions, that we are going to discuss very clearly and separately. But right now, how we can implement the definition of loss and gain of electron here, you can see this thing, that copper is an element which has +2 charge before reaction, but after reaction its charge is becoming 0. How we know the charges? Somehow we have discussed the charges thingy in case of periodic table, but here we are going to discuss these charges in detail again, so that you people may be able to take all the ideas about the charges together. So this is how the compound, the copper oxide, has broken into its components and copper's oxidation state, or you may say the charge is decreasing. Copper has lost the 2 electrons initially, but now copper has gained the 2 electrons back. As a result, its charge is becoming zero. You may say this thing that this equation is happening Cu plus 2 and plus 2 electron converting itself into Cu0. Okay, so this equation is occurring over there. This is the thing we are discussing here. Okay, so that's why we can say this thing that copper is undergoing reduction. Okay, and as copper has lost oxygen, that's why it is undergoing reduction. Then we are going to implement the third definition of redox, the oxidation and reduction, and that is about hydrogen. Okay, so what about the oxidation? Oxidation is loss of hydrogen, and reduction is gain of hydrogen. Okay, gain of hydrogen. We can say this thing that N2 plus 3H2 in a reversible arrow, it is making 2NH3. What is 2NH3? It is NH3 is ammonia. According to the balanced chemical equation, we have to write these numbers. Okay. So now nitrogen is gaining hydrogen as gaining hydrogen, so undergoing reduction. Okay, I am going to give you another definition as well. Here we cannot talk about the loss of hydrogen, but if we are talking about the reversible reaction, guys, reversible reactions are those reactions. We will discuss reversible reactions in detail as well, but right now, as I have just mentioned, our reaction, reversible reaction, so this is my responsibility to inform you what is a reversible reaction. Sometimes examiner is asking what is a reversible reaction. A reversible reaction is that in which reactants are converting themselves into the products, and products are breaking up to give the reactants back. Reversible reactions are represented by such type of an arrow. In one exam, examiner has drawn these arrows and then he is asking what is represented by these arrows. So what is the answer? A reversible reaction is represented by these arrows. Okay, so I am on the next page. Here I am going to take the example of H2O. Okay, so this is water, and when it is electricity is passed through it, this water is going to break up into its components. So what will be the component? It will be 2H2 and O2. Okay, so as oxygen has has lost hydrogen, so oxygen is oxidized. Oxygen is undergoing undergoing oxidation or you may say that oxygen is oxidized. Okay, so this is the definition number 3 which we have implemented regarding hydrogen. Okay, now I am on the next page, and here we are discussing the last definition of oxidation and reduction, and that is the definition number 4, and it is about oxidation state. It's a new thing. Okay, what that term is telling you, oxidation state is nothing but charge. Okay, so if oxidation state is increasing, then in a reaction, if it is increasing, then we will say that oxidation is happening. If oxidation state is decreasing in a chemical reaction, then we can say that reduction is occurring. Okay, so overall, we can tell that oxidation or reduction is occurring based upon oxidation state. Now, what is oxidation state? We have just discussed that oxidation state is the charge of an atom of an element in a compound. Okay, or overall the charge on an element is called as oxidation state. Okay, so for example, let's discuss, this is zinc. It's a very common and a famous reaction. It is reacting with copper sulfate and it is making zinc sulfate plus copper. This reaction is involving lots of concepts which I'm going to discuss when we are going to discuss this chapter. But right now we can say this thing that zinc has a charge of 0 before reaction, but after reaction its charge is changing to +2. And what is the charge of copper before reaction? It is +2 before reaction, and after reaction it is 0. Guys, we have already discussed about sulfate. When we have discussed about sulfate in the topic of bonding and in the topic of atomic structure, I have discussed with you there is a list of polyatomic ions. What was an ion? Define ion. Ion, ion. Ion is an atom of an element having charge, is called an ion. Ion can be a positively charged particle, can be a negatively charged particle as well. If an ion is formed by loss of electron, it will be a positively charged particle. But if an ion is formed by gain of electron, it will be a negatively charged particle. Okay, that is the discussion which we have done in case of bonding. I would like to write few of the words again. What was an ion? A charged particle. Charged particle. One more thing which I would like to inform you: an atom of an element having charge is called an ion. Ion can be positively charged, can be negatively charged. Okay. Positively charged ions are called as cation. Negatively charged is called anion. Negatively charged ion is called anion. Okay. So metallic partners, metals are losing loss of electron. You may say loss of electron is happening here, and hence a positively charged ion is formed. Okay. What about the non-metals? Non-metals are undergoing gain of electron and they are forming negatively charged ion. Okay. And then there is one more concept, that there is one thing which is called as a radical. A radical is also called as polyatomic ion. Polyatomic ion. The list of radicals have been already shared with you. This is called as sulfate. It has a charge of -2. Okay. So here you can say that it was -2 before reaction and -2 after reaction. So no difference in case of sulfate. But what about zinc? We can see this thing that zinc has been oxidized. How it has been oxidized? Because it has lost two electrons. Initially, what was the charge? 0. It has neither lost nor gained any electron. But after the reaction, zinc has gained the charge of +2. How? Because zinc has lost two electrons. So we can say oxidation is occurring over there. I'm changing the color. Okay, take red. Okay, so this copper is, okay, no, not this line. This copper is undergoing reduction. How this copper is undergoing reduction? Because the initial charge on copper is +2, but after gaining two electron back, it is turning itself into copper 0. So it is just telling you that oxidation state of copper is getting lesser, whereas oxidation state of zinc is getting higher. So zinc is undergoing oxidation, whereas copper is undergoing reduction. Number 2 point is this: why this reaction is happening. Before moving ahead, I would like to inform you that there will be a topic which is called as metals and their extractions. In that topic, we are going to discuss the reactivity of different metals as well. But right now, I'm just telling you that zinc is more reactive as compared to copper. So zinc is going to zinc is going to displace copper from its compound. You should have this idea that a higher reactivity metal is going to replace the low reactivity metal from its compound and will make its own compound. Same thing is happening over here. I'm going to give you another example regarding this. For example, just consider the reaction between magnesium and you may consider iron nitrate. Okay, so you can say this thing that magnesium is going to replace iron, will make magnesium nitrate, And after the reaction, iron will become free, so it is 0 and it is plus 2, it is 0 and it is plus 2. We can say this thing that magnesium is undergoing oxidation, whereas iron is undergoing reduction. So this is what happening over here. Okay, this is the basic concept about oxidation and reduction. In this video, I have just told you that what is oxidation and what is reduction, what are the four definitions of oxidation and what are the four definitions of reduction, how oxidation and reduction are always occurring parallel but occurring opposite to each other. After this topic, I am going to introduce you to words oxidizing and reducing agents. We will discuss this thing, what are oxidizing and reducing agents and how they are different from each other, what are the color changes associated with them, etc, etc. So I am just writing what will be the next topic: oxidizing and reducing agents. This will be our next topic. Okay, thank you very much, guys. Take care of yourself.